Part B, we're going to minimize that objective function. So let's look at the constraints here. First constraint, do your cover-up method. The x-intercept, cover up the y, is going to be 10. And your y-intercept, cover up the x, is going to be 5. So we've got an x-intercept, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And a y-intercept at 1, 2, 3, 4, 5, right there. Okay. So if you want to extrapolate, you can go over 10 and up 5, and you'd be 1, 2, 3. About right there, I guess. Okay, so use your line tool. There we go. That's not very good. Let me see if I can fix that. I don't know if I can fix that or not. Yeah, that's a little better, I guess. Maybe. Okay. All right, so we're going to shade up. We can see because of that greater than. Greater than, we're going to shade up. Okay, so keep that in mind. Keep that in mind, and you can deal with that later, but we're definitely going to shade up. All right, for the next one, you know, the x-intercept is kind of weird because if you cover up y, you're going to have 3x equals 10, and I know that doesn't come out even, all right? It doesn't come out even, but that's okay. You can deal with it. Think about it. You just divide by 3, you're going to get 10/3. That's 3 1/3. If you use a calculator, you get 3.3 repeating or whatever. I think a fraction would probably be easier to deal with here. 3 1/3. That's fine. We can do that. 3 1/3. So go over 3, and it's hard for me, but it'll be easier for you with your pencils. But go over and put about, 3 1/3 of the way right there, ish. Okay. And then the y-intercept, you're going to cover up the x, and you're going to get a y-intercept of 10. So y-intercept of 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 right there. And use your line tool. Right there. Okay. Notice the inequality symbol there says greater than, so that one's also going to be up. So, look, it's going to be up from both of those shapes. So look, okay, look, you're going to be shading in right there. Okay, up from both of those lines is there. Everybody wants to shade there, but that's not what it says to do. Okay, it says up from both of them, so make sure you pay attention and do what it says to do. So then x is greater than 0, greater than or equal 0. That's a vertical line. That's a vertical line, and we're going to shade to the right. And y is greater than or equal 0 is a horizontal line, and we're going to shade up. Okay, so think about it. If we have to go up from both diagonal lines and to the right of the vertical and above the horizontal, we're going to be in here. Okay. This is called an unbounded region because it goes on forever. Okay, it's infinite. It's going on forever and ever and ever and ever and ever. And since this one is unbounded, oops. There wouldn't be a maximum, okay? Because I could just keep picking larger and larger numbers for this. I mean, if you're going to plug into that objective function of 2x plus 4y, if you said, let's plug in 10 and 10, that's going to be big enough. But what if I say, well, let's plug in 15 and 15? Or let's plug in 100 and 1,000? Or let's plug in 1 million and 27 million? I could just keep getting bigger and bigger and bigger and bigger and bigger. This one is unbounded, and this one has no maximum. But that's not what we're doing. We're minimizing this one. We're trying to find the minimum. So look at your corners. I see a corner point right here at 0, 10. And I see another corner point right here. Does that look like it's right on a tick mark to you? Can you tell? If you can tell, you write it down. If you can't tell, you better go to Desmos. Mine looks like 2, 4. Okay, be careful, because if your graph's not real good, if you didn't draw your graph real neat, sometimes you might see the wrong point. Okay, so be really careful and draw these really neatly. And if you need help, go to Desmos. And that other corner right there is at 10, 0. So I've only got 3 corners. I've only got 3 corners that form my boundaries. Okay, so I'm looking for the minimum for those 3 corners. So just do what we did before. Take those corner points and plug them into the objective function. That's the objective function. 2x plus 4y. 2x plus 4y. That's going to be 2 times 0 plus 4 times 10. That's 40. And 2x plus 4y. It's going to be 4 plus 16 is 20. And 2x plus 4y. That's 20. Okay. So notice we're finding the minimum this time. We're optimizing, but we're finding the minimum. And the minimum appears to be 20, right? This one's kind of weird because there's 2 different 20s. But we're just going to say minimum z equals 20 at 2, 4, and 10, 0. That's a 10 right there. All right. Cool. One more. Number 3 says find the maximum and minimum value. So we're doing both, but it's still really, it's the same problem. Okay. So first go to the first constraint. Skip over the objective function. You can do that later. Okay. For the x-intercept, cover up y, and you're going to have an x-intercept at 12. Okay, well, my graph only goes to 11, so let's just eyeball it up and put a 12 out there. Okay, you could change the scale if you want to, but this one, the graph paper is kind of small. It's going to be kind of hard to do that. I don't know. I'd rather just go to 12. Honestly, you're not going to agree with this, but it's honestly easier if I don't give you graph paper on these problems because you can draw it as big as you want. But anyway, here we go. The y-intercept. Anybody know what the y-intercept is? 3. That's correct. Very good. 1, 2, 3. Okay. Once you get the hang of that, boom, it's easy. It's quick. You got 12. You got 3. You shoot a line through. Okay. Now the other one's tricky because of the negative. Okay. The x-intercept is 0. Ooh, and the y-intercept is also 0. Okay. So this is tricky for another reason. We only have 1 point. Okay. Sometimes people will watch my screen here. They'll see the y-intercept and the x-intercept are both 0, and then they'll just shoot a line through like this. Okay? You have no idea if that's actually the line. Okay? We only have 1 point. We don't have 2 points. We don't have enough information to draw a line. Definitely not that line. Okay? So we need something else. Okay? The intercepts method isn't going to be good enough on this problem. So you've got a couple of choices. One choice is to put it in slope-intercept form. Okay? So x minus 2y is less than or equal 0. I'd subtract the x over, and I'd divide by negative 2. Don't forget, when you divide by a negative, you flip the symbol. That says y is greater than or equal 1/2 x. Okay? That's probably the best way to do it because you see how the symbol flips there? It looks like we were going to shade down, but now we're actually going to shade up. Okay? So think about how to graph that using slope-intercept. You'd start at 0, and you'd go up 1 and over 2, and up 1 and over 2, and up 1 and over 2, as many times as you wanted to. And you draw a line through. Okay? Now notice, that first one was y greater than, we were going to shade up, and the second one looked like down, but when we flip it, we're actually going to shade up. So we're up from both of those diagonals. Okay, so think about where that is. That's actually right here, right? Okay, up from both of those diagonals is in that region. Okay. But let's do another one here. All right, 2y minus x is less than or equal 6. So the x-intercept seems backwards, but whatever. If you cover up the y there, you'd have negative x equals 6. So the x-intercept is actually negative 6 there. 1, 2, 3, 4, 5, 6 right there. And the y-intercept, cover up the x, you're going to get 3. So we've already got that 3 right there. Okay, so looks like we have 2 parallel lines. Okay, and this one is less than, so I'm going to shade down. Okay, there's no, you only flip it when there's a negative in front of the y term, because that means you were going to divide by a negative and you want to flip the thing. So that negative right there doesn't mean to flip it, only when it's a negative y value. So if I'm going up from the first two and down from the third one, it looks like I'm going to be shading inside there, correct? Okay. But then you've also got x is less than or equal 6. That's going to be a vertical line. 1, 2, 3, 4, 5, 6. Missed. Vertical line right there. Let's try that again. Line shape. That's better. Okay. And shading to the left. So that means we're shading inside this region. That's the feasible region. That means if there is an optimum, if there's a maximum, if there's a minimum, it's inside that region. Okay. It's actually going to be one of the corners, but there you go. So here's a corner right here at the point 0.03. And here's a point right here at 4.2. And this one is, I've got 6.3. And this point is 6.6. Once you get to the corners, you finally get to go to the z equation. That's the objective function. We skip that. We don't even look at it until the very end. And then we start plugging it in. Okay? So plug in the points. We've got x plus 10y. So x plus 10 times y, that one's going to be 30. And x plus 10y is going to be 24. And x plus 10y is going to be 36. And x plus 10y is going to be 66. Okay? So you look at those numbers. And the last part is you answer the question. Find the maximum and the minimum values. Well, it looks like the maximum, z, equals 66 at the point 66. And the minimum z is 24 at the point 42.